Hello everybody, 3.1, starting a new chapter, chapter 3. This is Algebraic Expressions. As it says here, parts of algebraic expressions are called terms. You might have heard like terms before. That is something we're going to be talking about quite a bit. As it says, they're terms that have the same variables raised to the same exponent. In other words, 2x and 5x. Those are like terms. It says raised to the same exponent here. This isn't written, but it's to the power of 1, so they have the same exponent, so those would be like terms. On the flip side, if I said 3y squared and 4y squared, those again have the same exponent, so those are like terms. Obviously something like 1 and 2 are like terms. X and 3x are like terms, just to give you just kind of an idea of what those are. Alright, let's look at some practice problems that we can start looking at. The directions for these problems are identify the terms and the like terms in each expression. So let's divide this in half here, and let's first look at our terms. 9x minus 2 plus 7 minus x. Our terms are 9x. Now we have to be careful here of negative signs. This is subtraction of 2, so we have to look at that as a minus 2. Plus 7, which you don't really ever need to actually write the plus, but I do want you to be aware that that is obviously positive, and minus x. The like terms of these, we have these two, and obviously these two. So we have 9x and minus x, those are like terms, and then minus 2 and 7 are like terms. B, it says z squared plus 5z minus 3z squared plus z. So my terms, let's start with terms. We have z squared, 5z minus 3z squared, and z. So what are my like terms there? Well, my like terms would be z squared and minus 3z squared. And other ones are 5z and just plain z. So these are like, and these are like terms. Okay? Next, we combine like terms. You want to simplify this, so we want to combine like terms that we have. Well, let's identify our terms here. You should understand now that 3/4 y, excuse me, and the minus 1/2 y are like terms. The 12 and then the minus 6 are like terms. So I want to simplify this. I'm going to write 3/4 y, and then I'm going to subtract the 1/2 y. Again, we cannot ignore this subtraction. We have to understand that we're subtracting 1/2 y from the whole expression here. So I'm going to subtract these two. I got to find a common denominator, which is 4. That's 2/4. So I'm going to subtract 3/4 y minus 2/4 y, and I'm going to get 1/4 y. My other like terms here are 12 minus 6. So I'm going to be left with 1/4 y, and 12 minus 6 is just 6. Now, think about that. I'm plus 12, taking 6 away. I'm going to be left with a positive 6. Positive 6. Basically, that becomes 12 minus 6 is how I got that. So this is my answer here for simplifying like terms. 1/4 y plus 6. Here's another example problem. It says simplify negative 1/2, parentheses 6n plus 4, plus 2n. Well, first I have to simplify. I have to bring that negative 1/2, and I have to distribute that into this problem. So I'm going to look at negative 1/2 times 6n. Well, how do I multiply 1/2 times 6? I'm going to make this into a fraction. Negative 1 times positive 6 gets me negative 6 over 2 times 1 is 2. That becomes a negative 3. Don't forget about the variable n, so it becomes a negative 3n. I'm going to then multiply the negative 1/2, and I'm going to multiply it by the 4. So I'm going to put 4 over 1. Negative 1 times 4 is a negative 4. And 2 times 1 is 2. So I get negative 2. So I am, when all said and done here, looking at negative 3n minus 2, because remember I had a negative here, and then don't forget about this part of it, plus 2n. Again, I have to simplify, combine my like terms. Negative 3n, I'm going to add 2n now. So I'm at a negative 3, add 2, I'm looking at a negative 1n, and then just bring this down. I have no like term for the minus 2, so it's just minus 2. I can simplify that even more and just call that a negative n minus 2. I hope you're following that. That's kind of a lot. We'll keep working on these. Last example of something to see. This might look a little complicated. It's not too bad. It says each person in a group buys a ticket, a medium drink, and a large popcorn. It says write an expression in the simplest form that represents this amount of money. Well, let's look at the three things that a person is buying. $7.50 for a ticket, a medium pop is $2.75, and a large popcorn is $4. So just make it a simple problem out of this. $7.50 x plus $2.75x plus 4x. And you could put $4 if you wanted, but it's not going to really matter. This is each one of my expressions. This was my movie ticket. X represents how many people, because we're talking about the group. We want to know how much, if this is what one person spends altogether, how many would this be altogether? Well, really this is kind of overkill, because you have three different like terms. We might as well just combine them all together. If you're going to the movies and spending $7.50 and $2.75 and $4, and everybody's doing the same thing, how much are you adding? How much is each person spending? Excuse me. So I'm going to add the $7.50, $2.75, and the 4. I'm going to add all those three together. I'm going to get $14.25. So that's how much one person is spending. Well, I'm just going to make it an expression of this and say 14.25x, because x represents here, this variable x is going to represent how many people. If two people go, let's make it easier. If one person goes, it's $14.25. If 5 people go, you're going to multiply 5 times 14.25. If 10 people go, you're going to multiply that times $14.25. So bottom line, it's just an expression that by simplifying this, I know that per person it's $14.25, and I'm just going to plug in how many people go and spend that money, and it will tell me how much the group then spends based on how many people there are. Hope you followed that. It's a little tricky as well, but like I said, we'll keep practicing this when we get to class tomorrow. Have a great night.